So the second part of partial fractions, in other words, the second form of a partial fraction that we can get is when we have a repeated linear factor in the denominator, okay? So what this basically means is that you've got the same linear equation or the same linear expression, repeated in your denominator. Okay, so there are 4 different types of partial fraction you're going to come up against. This is the second of those 4. So the main battle you're facing when you're dealing with partial fractions in an exam situation is knowing what to do with that individual example. So it's going to be one of these 4 different types of examples. This is the second thing to look out for. So as you might imagine, okay, when you're taking a fraction of the form cx plus d over ax plus b all squared, so it doesn't have to be written like that. It could be ax plus b times by ax plus b. Obviously, it's the same thing, but the point is that is what we mean when we say a repeated linear factor in the denominator. Right, what you might expect is that the general form of the partial fraction would be something along the lines of this: a over ax plus b over ax plus b. But if you remember back to National 5, when you're dealing with a fraction like this, okay, all that's going to happen here is that because the denominators are the same, we can just add the numerators and the denominator stays the same in our answer. In other words, not giving us ax plus b all squared, okay? Right, that will happen as well. So if you make the denominators in your partial fractions ax plus b squared, if you make them both that, then all that's going to happen is you're going to add the numerators, and you're not going to get the form that's desired. You're not going to get the cx plus d. There'll be no type of x, and it will also cause problems in terms of our working out. Okay, so the way that we get around this is that we want to make 2 different factors on the bottoms of our fractions. We need our denominators to be different. So the only way to do this and still make a denominator in our final answer of ax plus b squared, okay, is to make one of the denominators ax plus b and the other one ax plus b all squared. Okay, so we're going to split the 2 up into ax plus b as one denominator, ax plus b all squared as the other one, and then we can just go through the same process as we had before. Okay, but this then gives us, as I say, the general form. So you can memorize it like this if you want to, but what I suggest you do is you just do enough practice in partial fractions to get used to these different forms. Okay, some of you might find it easier to memorize an equation like this. It's not necessarily the way that I work, but I'll have these all written down at the end for you, and you can kind of use them as you wish. But if you've got a repeated linear factor in the denominator, this is the kind of process that we're going to do. So I'll give you a couple of examples now. Okay, so we've got a different way of asking the question. So I think I had decompose in the first part. For your question, it might just say reduce. Either way, it's dealing with partial fractions. And we want to split this up into its partial fractions. So we've got 3x over x minus 2 all squared. So the fact that it's squared means that it is a repeated linear factor in the denominator, so we have to follow the process that we just discussed. Okay, in which case we want to split it up into something over x minus 2 plus something else over x minus 2 all squared. Okay, right, from here on out, it's just the same as what we were doing before. Okay, what we've basically got is we've got an equation. Okay, we've got an equation that we want to solve in order to find a and b. Right? There are obviously different ways of solving equations like this, but generally I think when you've got fractions, you want to try and get rid of those fractions. So similar to what we did before, if you multiply through by x minus 2 all squared, okay, then the fractions will disappear. Just be very, very careful with what you're left with when you do that. Okay. So multiply this side by x minus 2 squared, obviously you're just left with 3x. X minus 2 squareds will cancel out. Each individual fraction multiplied by x minus 2 squared. If you multiply this one by x minus 2, the x minus 2 disappears, in which case you're just left with a. So then when you multiply it by another x minus 2, it becomes a times by x minus 2. And then with this fraction here, if you multiply by x minus 2 squared, you're just left with b. Okay? So in many ways actually simpler than what we were doing before. But you have to get this general expression right in the first place. Okay? So again, same as before, just solving it now. What we've got is we've got 3 different variables. So we want to do something to get rid of those 2 of those variables. So we're going to let one of the letters, in other words, the x, equal something in such that 2 of the variables will end up disappearing. So by letting x equal to something, obviously that's making x disappear. But then by making it equal to 2, it makes this bracket equal to 0, in which case the a is multiplied by 0, so that disappears as well. Okay, so just again, be careful when you substitute in. 3 times by the 2 that we've just allowed gives us 6. This disappears, becomes 0, and then plus the b. In other words, 6 equals b, b equals 6. Nice and straightforward. Right, the difficult bit here is that now we don't have, going by what we were doing before, we don't have our bracket to make 0. Okay, so what we can do here is we can just pick any single number that we want. Okay, literally any number, but obviously you want to make it as easy as you possibly can for yourselves. In other words, the easiest number to probably pick is 1. You can pick 0, but 0 might cause problems on the left-hand side, depending on what it is. Okay, yeah, 1 or 0 I think would work here as well. So let x equal 1, in which case we've got 3 times by 1 on the left-hand side, which is 3. 1 minus 2 is minus 1, times by a is minus a, and then plus the b, which we already know to be 6. Okay, so then we're left with this equation: 3 equals minus a plus 6. Solve it, take away 3 from both sides. Minus a equals minus 3, in which case positive a equals positive 3. Be careful with your negatives. There's going to be a lot of negatives throughout this advanced sci course. Gives it some practice now. Okay, if you're struggling with it a little bit, then go back and have a look at it. Okay. Right, in terms of what I've marked so far, I haven't seen anyone doing this next mistake, but it's a common thing. You've got to write your answer, okay? The answer is not that a is 3 and b is 6. The answer was to actually split it into partial fractions, in which case we've got 3 over x minus 2 plus 6 over x minus 2 all squared, okay? So that's one example for you. I've got another one for you. Right, this is basically just where we have 3 basically factors on the bottom, 2 of which are repeated. Okay, so it's kind of a combination of the 2 examples that we've done already. So when we split it up, it's just going to be a over x plus 2, b over x minus 1, and c over x minus 1 squared. Okay, so very similar, as I say, to the last one. We've just got this extra fraction to contend with. Okay, we still go about it in the same way. We're still going to multiply 3 by the denominator to get rid of those fractions. Again, just be very, very careful of what you're left with when you do that. On the left-hand side, by multiplying the denominator, you're just left with the numerator. When you multiply this by x plus 2, it becomes a. So then when you also multiply by x minus 1 squared, it becomes a times by x minus 1 squared. The middle fraction, when you multiply it by x plus 2, obviously it's going to be b times by x plus 2. When you multiply by 1x minus 1, the x minus 1 on the denominator disappears. But we've got 2 of them because it's squared, so it becomes b times by x minus 1, also times by x plus 2. And then the third fraction there, we multiply by x minus 1 squared, the denominator disappears, we multiply by the x plus 2, and then we have c times by x plus 2. So just go through it carefully and make sure everything's getting multiplied, okay? So now we've got an extra variable to contend with, okay, but we're still going through the same process. Just see what happens here, okay? So we're going to let x equal to 1, the idea being that we've got 2 of these x minus 1s over here, in which case when we make x equal to 1, this whole bit will disappear, and this whole bit as well will disappear, in which case we're just left with a c, which makes it nice and easy to find. Just go through it carefully. 1 squared is 1, 7 ones is 7, so 1 minus 7 is 6, plus the 9 is 3. Disappears, disappears. 1 plus 2 is 3, times by c is 3c. 3 equals 3c, c equals 1. Okay. Right, if we let x equal to minus 2, then these 2 will disappear. Okay. But as I say, just go through and check that, and just make sure you do the left-hand side carefully. It's negatives, so there's a couple of things to contend with here. Minus 2 squared is positive 4. 7 times by minus 2 is minus 14, but we're taking it away. In other words, we're taking away a negative, so we're adding it on to 4, which gives us 18, plus the 9 gives us 27. Disappears, disappears. Minus 2 minus 1 is minus 3. We square that, we get positive 9, times by the a is 9a. 27 equals 9a, a equals 3. Right, so then for the last bit, we still need to find out what b is, but there's nothing we can actually do in terms of a singular number to make the other 2 disappear. Okay, so we just have to pick a number, okay, an arbitrary number, and use the values that we already know in order to find b. So I'm going to make x equal to 0. I can't make it 1 because I've already done that. So I'm going to let x equal to 0 here. Okay, in which case we have 0 squared, which is 0, minus 7 zeros, still 0, plus the 9 gives us 9. When I make this x equal to 0, it's minus 1 squared, which is positive 1, so we're just left with the a. Careful with these two. 0 minus 1 is minus 1, 0 plus 2 is 2, minus 1 times by 2 is minus 2b, and then the last one we have the 2c. Okay, I can't solve that by itself. Okay, you could have done that one first if you wanted to, but you're going to need your a and your c values to be able to find out what b is, so substitute them in now. 9 equals 3, that's our a, minus 2b, still don't know that, but c is 1, so I'm going to have 2 on the end, and however way you choose to get to the final answer, it's just a case of solving an equation. Either way, b equals minus 2. Again, be careful, that's not our final answer. Our final answer is when we put it all together and get ourselves our 3 fractions split up from the first one, okay? So just be careful how you put them in terms of the order. It's 3 over x plus 2. It's minus 2 over x minus 1, which again we can write as minus 2 over x minus 1, and then plus the 1 over x minus 1 squared at the end. Okay, so that's a repeated linear factor in the denominator, and there's 2 more to come.